to share my screen.
Okay, everybody, welcome to the February N3C Community Forum. Next slide, please. So as usual, this presentation will be recorded so you can catch it later, and it'll be archived on the YouTube channel. And for those of you who have questions, just go ahead and throw them into the Q&A, post the questions and we'll monitor that, or you can raise hand and we can unmute you with the microphone if you want to speak. Next slide. And as Tristan mentioned before, we are moving to a monthly meeting starting this month. So we're going to be on the second Monday of every month, same time, 5 p.m. Eastern and 2 p.m. Pacific time. Next slide. And just an update on the N3C data enclave. We are up to 22 million people in the enclave with 8.7 million cases of COVID. So we just have this enormous data resource, which is wonderful. Next slide, please. And upcoming forum presentations are as follows. In March, it's still to be determined, but in April, we're going to be talking about we're going to hear about the SEER Cancer Registry, and then in May, COVID-19 among disability populations, and in June, we're going to be talking about algorithmic best practices. Next slide, please. And with great pleasure, I'd like to introduce Kate Bradwell and Saad Ljazouli, who come from Palantir and are going to be talking about AI integration of in the Enclave to enhance researcher productivity. So we're going to hear about new tools and very excited to see the work that you've done. And I'll let you guys take it from here.
Great. Thank you, Rachel, for the intro. So this presentation is about the new AI and LLM-powered capabilities that are available in the N3C platform. Let me share my screen. Can you all see this?
Yes.
Great. So this is an outline of what we're going to be talking about today. Mostly showing these AI capabilities through examples and various use cases. But first, I wanted to give a brief update on a new data type that is available in the platform for use. Then I'll talk about an AI capability called AIP Assist, which is a general Foundry capability that was added to the platform, and show through examples how it works. And then Kate, my colleague, will take over and talk about other AI capabilities that are more specific for the N3C context and more useful for using LLMs in the context of N3C and N3C data. So great. So the first thing, and this is just a brief update. Since the past 2 weeks, we've added a new data type that has to do with cancer cases from the SEER registries data. So SEER registries are this data source managed by NCI, the National Cancer Institute, and it mostly contains cancer cases for people across the US. And so within N3C, we were able to ingest that data from SEER and link it to the EHR data so to be able to, on the patient level, be able to have EHR data and SEER data jointly. So I'm just going to show briefly where the data lives, how to request it, and how to use it, or at least import it in an analysis, just to make it more practical. So the first thing, if you go to the N3C homepage and you go to the data catalog, one of the data collections is a PPRL linked data set. So for the case of SEER, just like we did previously with CMS and mortality, we were able to get that data, and using PPRL, or privacy preserving record linkage, link that data to the EHR, the patients that are within the N3C EHR. So if you go to the PPRL linked datasets, you'll now see that there is a new collection called Cancer Registries from SEER. And if you open it, provided that you have been approved to use the data, you'll see 3 tables. The main data set is this SEER registries dataset, which is a wide dataset containing cancer cases. But you also have a dataset which is more of a data dictionary. This data dictionary is available now, even if you don't have a DUR in place. This is publicly available, so you can see the fields that are available even before applying for a DUR. And we also have, when you have a DUR in place, a mapping table. This is mostly to give this mapping between N3C person IDs and the SEER record IDs so that you're able to link the patients. So all of that is available in the data catalog. Now, going back to the homepage, I'm just going to show briefly how to request access to it. So there are 2 methods. The first one is when you're creating if you want to create a new project and a new workspace to analyze N3C data, you would go to this data use request tile, and then you will fill a data use request or DUR form. In order to access and request SEER data, your request has to be for a limited data set or level 3, which requires an IRB. And then in the PPRL external datasets section or dropdown, there is an option to request access to SEER dataset, just like there is, and there used to be an option to request access to CMS, mortality or viral variants. All of those are sources that are not EHR, but we were able to ingest and then link via PPRL. So that's method number 1. This is for creating a new project. In case you have already a workspace in N3C that is, say, level 3, and you want to upgrade it to have access from the same workspace to the SEER datasets, you can go to the My Projects dashboard, and this shows all the research projects that you have access to. In my case, I don't have any, but I will switch to a view of Dr. Ken Gerson, who has a number of projects that he's part of. And so if I click on, say, this project, NCAT's investigation into drug efficacy, what you want to do is you want to request to upgrade this project. So there is a revise DUR button that you can click on, and this allows you to request access. So this project is already level 3, but now you can say, oh, in addition to the level 3 data, I want an additional access to SEER. And you can submit this revise, or we also call it a PLDUR. Once you submit that, the Data Access Committee reviews your requests, and when it's approved, you automatically get access to the SEER tables. And so the last thing I wanted to show in relation to SEER is, let's say now you have access. The way to import and use this data set in your analysis is to, I'm just going to create a code workbook, which is one of the ways by which you can analyze data, in this case, using code, or Python or SQL. So suppose I'm in my existing workspace here called Example Research Project, and I open a code workbook. You can just click import and then go to the data catalog that I showed earlier, and then navigate to the PPRL linked datasets and then to cancer registries to be able to import those tables. So I won't be showing these tables today because these are, some of them are real patient data, but I just wanted to show the process of requesting access, where to find the data, and how to import it to your workspace. So now enough about the updates on SEER registries. Going back to, yes, go ahead.
Yes, there was just one question that maybe you want to address now while you're talking about SEER, but it was, is it only SEER or also SEER Medicare linked data or SEER Medicaid?
So in N3C, you have the EHR, and you have the option to request SEER, which is its own data set. You also have the option to request access to Medicare and Medicaid datasets, which are available. But these are in your DUR, you have to check both in order to access them. I hope
Great,
that
thanks.
answers the question, but feel free to add more in the chat if anything is unclear. Cool. So going back to the AI functionality in the platform, the main thing I wanted to show before I pass it to Kate is this thing called AIP Assist. So AIP stands for Artificial Intelligence Platform, which is a collection of LLM-powered capabilities within Foundry, the platform that supports N3C. And so one of the useful ones is this LLM-powered tool that helps users to get the most out of the platform. And I'll show a few specific examples. The first example, I'll show 4 or 5 examples. The first one here is I'm looking at a code repository. So this is an application within Foundry where you can do your data engineering and process and write data pipelines and build them. I'm looking at a script here, which is a Python script that essentially just uses connects to the GPUs in the platform and then runs a simple code to test whether the GPU is working and returns some parameters about the GPUs. And this is the end result data set that this transform is generating. So this is just for the sake of example, and this transformation is a simple one. It is written in PySpark, which is a library, a Python library that runs on top of Spark. So one of the useful features that has now been added to the code repository is this thing called Ask AIP Assist, which gives you a number of options. One of them is just to provide a code explanation. So let's say I have a simple or a more complex transformation, and I want to get an explanation of what this does. I can just click Explain Code. And this will open this sidebar, which is the AIP Assist sidebar, that will then generate an explanation of what the transformation is doing. So this is essentially saying, this is calling driver GPU enabled, which is a profile that has access to GPUs. And that's just one example of like code explanation. I can, if I switch to another code repository here, this is another example that does some PPRL processing. So essentially what this does is it links the EHR data with the SEER data based on a global person identifier generated by the linkage honest broker. So here again, I'm going to click on Ask AIP Assist. And in this case, another use case that I wanted to show is instead of explaining the code, or maybe I can, let's explain it first. So it says basically what I just mentioned, that this code defines a data transformation, and it essentially performs a join to based on the GPI column. Now, let's say I want to do a conversion of this code to another coding language. So let's say I want this to be translated into SQL. I can just click on Translate, and then this generates the exact the same code, but written in SQL, doing the same data transformation. So this can be useful for research projects where people use or speak different coding languages to be able to translate between one another. Another example that I wanted to show here, I wanted to show an example of finding bugs in codes, which can be quite handy. In this separate branch, I basically have written a code that is similar, but that has a bug here, in that my join here doesn't specify any join key. So it's trying to join the EHR with the SEER data, but it's not specifying the column on which to join. So in this case, I'm going to click Ask AIP Assist and click on Find Bugs. Oops, I guess this did not generate what I would expect, which can happen with LLMs at times. Let me do something more obvious, which is basically performing a join, but returning a variable that doesn't exist. So this is a simple one where the code was able to, the LLM was able to identify just an issue with the join operation. There are times where this is able to identify a missing join key, but it sounds like in this case, it wasn't able to. But in any case, it could be quite handy in identifying at least obvious errors. Another example where the bugs explanation could be handy is if you're looking at build errors. So if I switch here to this is a view where I've run a build on a number of data sets, and some of them were failing for some obscure Spark reason. So there's an AIP explain feature here that reads the logs and then gives you an explanation of why, in this case, the Spark job was killed. You can also do it on a transform level. So looking at this data set here and opening up the build error, you also can see and explain the logs feature here. It's going to take some time to think and then it will generate an explanation for the logs. So let's just give it a few seconds. Seems like your build was killed, and this can happen for these various reasons. So another way to try to understand build failures in Foundry. Now, moving on to other AIP assist features. Actually, before what you're looking at here is Pipeline Builder, which is a tool where you can write and build data pipelines using no-code widgets, so without necessarily writing codes. And in this case, I preloaded this table, concept sets members, which is a collection of concept sets that have been defined in the platform, and the condition occurrence, which is a table that contains the list of conditions per patient. In this case, I've uploaded the notional data. So what you're looking at here is not real data. But looking at concept set members, one of the typical things or queries that people start with is starting from the concept set members table, filtering to a concept set of interest, and then looking at the corresponding domain table to try to filter down to the cohort or the phenotype that the concept set attempts to define. So Pipeline Builder does have the AIP explain feature that I was showing in code repository, but the interesting one here is that it has this additional feature to kind of generate the transformation based on some text that you write. And so in this case, what I'm going to do is I'm going to click on AIP generate and then select these two tables. And then what I wanted to do is say something like filter to a concept set here, and then join with the condition occurrence table. So let me just pick an appropriate concept set to filter on. So let's say I believe there is an influenza cohort concept set that I was testing with. So I'm just going to do that. I'm going to say filter to influenza cohort concept set and then join with the condition occurrence table. And let's click on generate. So this will take a few seconds and should hopefully generate a transformation that does exactly what I was describing in um, by using natural language. It says constructing the pipeline. Whoops. Let's just try that again. Filter to influenza cohort and join with condition occurrence. I think that's right. And while this is loading, I wanted to show another, oh, there you go, it's done, so I can show it now. So as you can see here, it has two transformations. The first one, if we look at the data transformation, it is essentially starting from the concept set members table and then filtering to the concept set name is equal to influenza cohort. So if I want to be very more specific, I would have to specify the version of the concept set or the code set ID in my text, but this is more to show the concept of it. And then the second step that was already generated based on my text is if I look at the preview, this is a join, and it's essentially joining my filtered concept sets members table with the condition occurrence table based on the concept ID. And so you can see the results of the preview here of the query, or at least the preview. And so all of these are supposed to be influenza cohort concept sets. So these are all concept IDs that are part of that concept set called influenza cohort. So again, another feature that where you can use AIP's help to help you speed up your data transformation. And of course, just like the other features, this is more of a helper. And you always want to be double checking the transformation or double checking the answer given by the LLM. But in some of these cases, especially when it comes to checking syntax, explaining PySpark code, it can be very useful. And then the last thing that is also AIP assist related, and let me open it in a separate tab. You can use AIP assist to ask general Foundry platform questions that you don't know the answer to. So on the sidebar here, there is an AIP assist. There is an AIP assist sidebar. Let me actually, second. So let me say, I'm going to ask a question about how to write and how to train machine learning models in Foundry using Jupyter Notebook. So I think I've written a question here. So let's say something like, how do I use Jupyter Notebook to train machine learning model in Foundry, which is a general question about the platform that could we typically get from people who are new to the platform. So if we ask this question, the good thing about this is that it will generate an answer, but then it will also link to the appropriate Foundry documentation. So here it's giving you the steps using Jupyter. So you should use Code Workspaces, which is our deployment of Jupyter Notebook and RStudio within the platform. You should make sure to have at least Foundry ML and scikit-learn libraries in your Conda environment. And then it's just giving you some steps to use and deploy the models and some links to the documentation. So this is like a documentation that is external to the platform that gives you examples on how to train models and how to save them in code repository. So just an example of the links generated by AIP Assist. So I think that's mostly what I wanted to show. So again, for recap, in code repository, you can ask to explain your code. You can ask for your code to be translated. You can find bugs, although unfortunately my example didn't work today for some reason, so I'll have to take a look at it, but it's usually quite helpful. And you can also look at the code explanation or the log errors explanations in the build logs page. I showed an example of generating transforms in Pipeline Builder simply by providing natural text. And then the last thing I showed is just using the sidebar to ask general questions about the platform. And that typically gives you an answer, but also links to relevant documentations in the Foundry docs that are available outside of the platform. So I think I'll stop here and then pass it to Kate.
Yeah, thanks, Saad. As helpfully pointed out by someone in the question and answer section, I think it's maybe because you highlighted a part of the code that it was trying to find bugs in just that highlighted part. And so that's might be why it wasn't working for that particular example. But
that's a good
yeah.
point. I was trying to, now that nothing is highlighted, let me just try again real quick.
While you're doing that, we had one other question. Is there a need to enable AIP in the code workbook? Or I guess somebody doesn't see it on their code workbook.
Yeah, it's not there yet, but we are working on it. So this is very the AIP platform is evolving quickly, and we're releasing features as we go, and it's probably why some of them that I've showed today give mixed results, but it's in the plans. And there are other features that are in the pipeline, and there are some of them which Kate will talk about today, but not yet in code workbook, but hopefully sometime soon in the future. I'll stop sharing.
Thanks, Saad.
Yeah.
I'll just share my screen. All right. So can everyone see this okay? Yeah. So as Saad has pointed out, there's the artificial intelligence platform, AIP features that are integrated, and they're basically trained on a lot of the general Foundry documentation. What I'm going to show is also features that we've integrated that are particular to researchers of the Enclave. So trying to instead train on objects and information and documentation that's actually particular to the Enclave rather than just in general to the Foundry platform. So we first asked ourselves when we were integrating LLMs for researchers, we asked ourselves what kind of tasks would researchers likely be interested in or interested in help with from LLMs. So these could be things like, due to the large amount of different object types, such as knowledge store objects, concept sets, community notes, LLMs can really help researchers in summarizing those wide variety of objects and their information, potentially summarizing documentation from those objects. You can imagine researchers also will be looking through knowledge store items, looking through concept sets, and a general keyword search might not be sufficient for retrieving like relevant objects from those collections. So in that case, semantic search is particularly useful. For example, you might go to the knowledge store and search for a model that defines or predicts long COVID patients. And what you would want the LLM to surface also is maybe a model that is defined as predicting past patients. We also envisage that researchers will be interested in automating manual tasks and want to increase their productivity. So things like defining concept sets. This is a very manual task. It could potentially be sped up and improved by the use of LLMs. So LLMs to try and use semantic search to gather relevant concepts or the proximity of concepts and suggest concept sets that then the researcher would likely just have to review. So those are the potential use cases that we were seeing in the beginning for LLMs. But I'm going to go into the first features, AI features in the Enclave that we've actually integrated and are currently available for researchers. So first, I'm going to bring up N3C Assist, which Maya developed on our team. And this really is an interface very similar to AIP Assist, but again, as I said, trained on the Enclave data and the Enclave objects and documentation. So often when researchers want to produce manuscripts, they may say want to export their code to GitHub and make that available as a link from their manuscript. So a common question we get is, how can I export code for GitHub from the N3C Enclave? So you might ask that question. You might be unsure as to which features, where to actually download your code if necessary. So N3C Assist has usefully taken that prompt, so the input prompt here, compared it to a lot of information from the documentation of Enclave objects, such as, say, documentation from the Book of N3C or documentation from the Knowledge Store or from training modules. And it's actually found the most relevant information to answer that question via semantic search through the ADA2 model and returned via another summarization prompt this result. So it's saying to export your code for GitHub, you'd want to go to, say, code repositories or code workbooks, and it actually tells you the gear icon that you need to look for and export Git repository. And then it shows you what type of information is then exported in the GitHub repo. So this is very useful. It also provides extra information, such as, you might want to ask extra questions in an issue or go to office hours to ask about this topic. So as I mentioned, kind of the backing is a function that actually takes your prompt. So this is the input prompt that the user had entered in to the N3C Assist box, and it creates an embedding of that prompt and then compares that embedding, which is a small snippets of information from the prompt, to other small snippets of information from all the different, say, training modules, documentation from the Enclave, and finds the most similar information, and then basically a summarization is performed using, again, another LLM that just summarizes the information through ChatGPT-4. Another tool that we've integrated LLMs into is Protocol Pad. So for those of you who aren't familiar with Protocol Pad, which is available again from the Enclave homepage, it's a set of guided steps to complete a real-world evidence study. So basically canonical steps that a researcher might want to take to complete a research study, guided decision support, just surfacing relevant information that you might need, such as knowledge store items, etc., throughout your study via an interface, which is kind of like a stepwise interface. And the first step to creating a protocol is just to create a name, such as your study might be factors influencing development of chronic obstructive pulmonary disease in N3C patients. And so your objectives might be, investigate factors influencing this. Just for brevity, you choose your research project. And then you've created your protocol. So you end up with a set of steps that you can see on the right-hand side that really guide you in the process of actually completing an observational study on the N3C data. There's a landing page also that includes a resource checklist of general resources that you might want to check into, and the criteria for each step or item you're seeing and how to complete it. In the interest of time, I'm just going to switch to a protocol that I've already mostly completed and just show you the type of information that's provided by the LLM. So the first piece of information that's provided by an LLM is it takes the objectives that you'd entered upon creating a protocol and actually determines the type of research study that you're performing. So this might seem like it's straightforward, but especially for observational type studies, there's case control, cohort, cross-sectional, and it might not be obvious to the first-time observational researcher what type of study they're actually performing based on their research questions. So this is really useful for, say, first-time authors or first-time Enclave authors. So it's identifying in this case for this protocol and in this example that this is a method study. Another part, just skipping ahead, is the LLM suggests knowledge store items that might be relevant to perform your research study. So for example, if you weren't aware of the knowledge store, this step really shows you that based on knowledge store items, there are these that might be relevant that you can look into, and you can click on them, and that takes you to a link to the knowledge store to show you that this is shared code that can be used to define certain variables or cohorts that are useful for this study. There are various other steps which just allow you to attach your analysis plan and record your analyses and results. But I'm going to skip ahead also to the last step of Protocol Pad, where LLMs are actually used in a summarization scenario. So it's actually summarizing all the information that you've put in the previous steps to actually suggest a draft introduction and materials and methods text for your study. So this is useful for actually reminding researchers this is the type of information that you might want to include, and might want to include also for reproducibility of the study, which is often difficult for researchers to actually remember all the items that they need to define, especially in the materials and methods section of a research article. So that said, we're also thinking of various ways to integrate more LLMs into these kind of interfaces. You can imagine maybe that a LLM can act in the role of a reviewer. So it could actually review even the text that it's written or summarized from all this information and say, all this information that you provided that we've summarized here, it can actually be improved based on, say, known structure of articles on observational research. It could also look at your analysis plan or methodology steps and suggest improvements to specific steps. So that's the future that we're seeing in terms of research decision support in something like Protocol Pad. Other kind of future use cases that we're seeing are potentially that if you have, say, a concept set of interest that you're thinking of defining, maybe you'd want to use LLMs to provide a more detailed comparison of existing concept sets that you might want to use. As it can process a lot of information and make a lot of different comparisons, it can provide a set of comparisons or a summary of comparisons that's much more detailed or dynamic than any interface that we can potentially design for comparing different concept sets. You could potentially want to, as I mentioned, use LLMs to help define concept sets in the first place. by finding semantically similar concepts. So going back to the summary here, just to recap, Saad showed the general AIP features of the Enclave. So the AIP features that are integrated into Foundry as in general. And I've showed some of the features that we're thinking either of integrating in the future or have already integrated for the Enclave that involve the use of LLMs. And so we'd welcome feedback and further questions, any other suggestions on potential use cases of AI and LLMs for the Enclave. And here's our contact details. Thanks for listening. And I think we can go to any further Q&A. Thanks.
Thank you both for that wonderful presentation. I'm going to maybe start off the questions just selfishly. I have a lot of stake in the game for defining concept sets for the queries, and we have had difficulties aligning them with different sites like CoreNet and PeteNet because of some of the ICD and SNOMED differences. Would we also be able to import concept sets and sort of do a semantic comparison of things like ICD if we, ingested those and then the SNOMED? Like for the different concept sets?
Yeah, that's, I think, definitely something that Andrew Gervin on my team is very interested in, potentially trying to integrate more, different vocabularies that may be useful for defining concept sets and enable a wider range of semantic search. But yeah, we'd welcome feedback on exactly what features would be welcome or needed for an enhancement of concept set definition, definitely.
And similarly for just things like trying to look through code to define things like maybe timing of like cohorts, the way they're defined, like by index date or something, could LLMs be leveraged to do something like this as an index date, or these are the this is a cohort that's defined by COVID in relation to COVID index date or some other kind of markers that would be descriptive in nature?
So with for example AIP assists, which is backed by GPT-4, it knows the OMAP data model, and so you can use that to as a query helper to generate your queries. But you'll probably have to do it with some smart prompt engineering, and then not necessarily taking the queries generated at face value, but that can help you with a starting point for your query.
Okay, I think I was thinking of it more like code review in terms of like, does the code match the semantic concept that we want, or does it match this cohort that we want?
I see. I mean, the explanation feature will probably give you a literal explanation of the operations done on your data. I'm not sure if it can go as far as a smarter review of like whether your clinical concept is well defined. So there still needs to be some expertise there looking at the query, but it can certainly save you some time.
Yeah, absolutely. I'm looking through the Q&A and there's no further questions, but just want to give people one last opportunity to ask Saad and Kate while we have them. All right, I don't see anything there. So thank you so much for that wonderful presentation and for the tools that we can all use in the Enclave.
Of
Thanks,
course,
Bob.
and as usual, people working in the platform can file issues on the platform if they have questions, and they can join office hours, and we can get hands-on help if they need to.
Okay, great. Thank you so much. And we'll see everybody next month.
Thank you. Bye.